is now recording. And let's share the screen. So the Jupyter notebook is here. And then we're going to go to this. All right, so so to get this to work, there's a couple of things that we need to do. So one of the things that we need to do is we need to start the Jupyter prompt. So in the Jupyter prompt, or not Jupyter, sorry, Anaconda prompt. So you can see here, I'm going to share that screen. Okay, so this is the prompt. And the reason why we need this is we need to install some programs. Okay, so we're going to have to install Tensorflow. By default is not made available in Anaconda. And so we have to use it here. So we have to install it. So if I go, all right, so we need to basically, to run this, we need to use the Conda environment. So we're going to create a Conda environment first. Okay, I'm going to go here, and I'm going to paste. Okay, that didn't work. Control C, Control V. All right, there we go. So we need to first do this. So we're going to be running from the Conda prompt, as I said. But for this to work, we need to create a Conda environment. So I'm going to do Conda create -n. I'm going to call it TF v2. Okay, that means TensorFlow version 2, and then I'm going to install TensorFlow. So if I do this now, I've already done this, so I don't want to do it again. What I'm going to do instead is I'm going to create, 365, and that way what I'm doing is I'm creating another environment called 365. Okay, so it's trying to install, as you can see here, the TensorFlow environment. All right, now I'm going to say yes, and it's installing. And you can have as many versions as you want, that's what Anaconda does. It allows you to have version control. So then you're going to have individual environments with, you could have different versions of Python. You can have one with 3.5, one with 3.7. Because they have different names, you can just reference them separately, basically. Okay, so it's taking a second there. All right, and it's done. Okay, so we can see it's done. Now we can proceed. Oops. And now we are going to look at the environment. So I'm going to do Conda environment list. You guys hopefully can see I'm typing this in the terminal. And you can see it's got several environments. So it's got the base, it's got these two environments, and then I had created this one initially, and then just now I just created 365. They're basically the same, so there's no real difference. And what's important about it is it includes TensorFlow 2. Okay. Now, Now we're going to go into the environment. So I'm going to do Conda activate. And then I can just pick the environment. So in this case, TF version 2. And I'm just, and let's say 365. So you can see now, instead of base here, instead of this saying base, it now says TF version 2 365. And that's it. So now I'm in the environment that I want. So that means now I have TensorFlow. But I also need a couple of other things. I want sklearn and keras. So I'm just going to do pip install. And then I'm going to do keras and sklearn. And this will install these here. Okay. Only to this environment. So only to the environment. No comma. Okay. Let me just do it separately. I'm going to do pip install keras. All right, says it installed it correctly. And then I'm going to do sklearn. All right. And it installs it. So now I have everything, hopefully, that I need, right? Everything that I need. So now I can proceed to create my, my environment, right? So my environment. So let's go ahead and just for convenience, we're going to do this on the Jupyter Notebook now. Now we'll come back to this, right? We can come back to this and navigate to the desktop. So for instance here, I'm going to go to CD desktop and then CD ITS is uppercase, doesn't matter here. All right, and right, so this is where I have all my scripts. And so I have a TensorFlow folder in there. You guys can hear me, correct?
Yeah.
Okay. All right. So I'm going to go into TensorFlow. All right. And in here, as you can see, I have a couple of files in there. Okay. So now we're going to start thinking about, we can run things from here, right? But just for convenience, let's just do this on the Jupyter Notebook. So now I'm going to switch over to the Jupyter. Okay, so here we are. We are in 365 TensorFlow. Now I'm going to create a new a new file in here. I'm just going to say I just have some other things I was working on, but let's create a new one. All right, and I'm just going to paste in here. So the commands I just typed, right? So these are the commands I just typed. I'll put this later on the. This is currently not on the GitHub, but I'll put it there later. And I have these libraries, right? These are the libraries. So as you can see, just before we've always done import numpy as np, but now notice we are doing import TensorFlow as tn. Okay, so this is our new library today. And the reason being is, as I explained last week, it just becomes less practical to implement deep learning just in NumPy alone. And so when we're doing actual deep learning, which is a neural net with more than one hidden layer, it just makes more sense to use TensorFlow or PyTorch or one of those. After that, you can see that I'm I'm calling keras here. And from it, I'm going to call, I can just try several functions. The models, we'll be using this sequential. Layers, dense layers, we'll be using this one. There's one called convolutional neural networks. We will not be covering that one in this class, but this is something that I cover in the deep learning class. And then here you can also see that from sklearn, I'm calling a few functions like fmeasure, precision, recall, confusion matrix, etc. All right, so let's just run this to see. Let's actually give this a name before I forget. Save as. Hold it. Simple deep learning. Simple deep learning. We're going to save it. Okay. I'm going to close it now. There it is, simple deep learning. Open it. Okay, good. Now I can go ahead and run this. And no module TensorFlow. Let me see if I just restart the whole thing. Okay, let's try it again. It might be that it's using the base. Now that I think about it, it might be using the base environment. So anyway, if it's using the base environment, then yeah, might be more convenient just to do this in the command prompt. So let me then, just going to create a script here. All right, so I'm going to call it simple deep learning. And I'll open this in a second. I'm just going to open it as a Notepad++. So simple deep learning. All right, so I've done the same thing pretty much. I'm going to share this now. So you should be seeing on the Notepad, same thing pretty much. But this time it is a PY instead of a .py instead of a Jupyter Notebook. I think with the Jupyter Notebook, I just have to select which Anaconda environment, and I didn't do that. So let's just do it here. All right. Let's add the print done. This should work. All right, so that's it. Let me save it. All right, so you can see basically a notepad. I just copied the libraries and the commands. These were the commands in the Conda environment. So now you can see here we're back in the Anaconda environment. If I do dir, you can see that my simple deep learning.py file is right there. So that one should run.
We still only see your notepad.
Oh, I'm sorry. Yeah. So I'm going to switch over to the prompt. All right, so I'm going to do CLS here. So you can see I'm in the prompt, right? This is what I was saying, the Conda prompt. Remember, I did activate TFV2 365. That just puts me in the Anaconda environment, right? This one does have TensorFlow because that's what we did. Remember, we typed type that one first to create the environment, TFV2365 with TensorFlow. Then we did Conda Environment list just to see what the environments we had. Then we activated TFV2365. That changes the name here from base to this name. And then we installed pip install keras, pip install sklearn, very much like Linux, like you guys are used to in Linux. And then now I created a file. Well, if I do dir, right? So if I do dir, you can see I have the file here. And then what I'm doing is I'm just opening it with Notepad++. That should be simple enough to do. All right. And so here we are now. I'm going to run that code. Just going to type Python and then simple and then .py. It's probably loading everything. It's taking a while. There we go. All right, so I think it only takes a while the first time around. So, you know, we did that. So you can see it printed done. So that basically means it loaded all the libraries without a problem. So now we have them available, right? So we have the libraries available. So that shouldn't be an issue. All right, so now let's start thinking about writing a simple program. So let's do. All right, so we're gonna do then. Let's see if we can load a data set, right? So let's see if we can load a data set. So I'm gonna do. Or actually, let's just use NumPy to create a data set. So we'll do that. All right, so now I'm going to switch over to the Notepad++. You can see that here. Okay, so let's initialize TensorFlow to some random data. So I'm just going to say tf.random. And this is only because I'm setting, I'm creating you know, some random data. So I'm going to do tf_random.set _ seed. Okay, and then I'm going to do also for NumPy the same thing, random dot seed. Okay, and both of these things just allow me to make, when I create my data randomly, that you know, I've initialized the seed basically. So now I'm going to create the X matrix, pretty much what we've been doing all semester. So NumPy random random.uniform, right? So random.uniform distribution. And we're just going to say that we want this to be, you know, some parameters. So low will be equal to -1. And then the high will be equal to 1. Okay, so basically from -1 to 1, okay? And then we're just going to set a size of, let's say, and this is important later on as we start to define the dimensions or the architecture of our deep neural net. So here I'm going to say 200, comma 2 features, basically. Okay, so I've created this. So this has 200 samples and 2 features. Then I'm going to create the labels. So here I'm just going to say for now np.ones. And it's going to be a vector of the same size as x, right? So all I need to do is length of x. By default, it'll just grab the first dimension, so 200. So both of them will be of size 200. This is 200 by 2. This will be 200, a vector of 200. All right, once we have that, we want to, this is going to be the classic XOR. This will be the XOR data set. And what that means is we're going to set the y's with a rule, right? So the rule is going to be basically pretty easily, we can just say y in square brackets. And then for those x's that meet a certain condition, the value will be set to 0. Okay, otherwise it'll be set to 1. So to do that, we can just say x. All right, so we're going to take the given, right? So the given row and column 0, and we're going to multiply that times in x for that same given row, but column 1. So basically, we're just, for every row, we're multiplying column 0 times column 1. Whenever those values are less than 0, we're going to set that value to 1. Remember that when we do something like this, it gives us the indices, right? So it's going to give us the indices that meet this condition, like an equality or a greater than or less than. So it's a type of a Boolean, right? And it's going to give us the indices. All right, and actually, because they're all ones, actually set it to 0. So now we have labels. So if we print the labels, if we print y now, we should be able to see that some are 0s, some are 1s. That really, we don't have to worry so much about that. So if we go back to the, here, I guess. Yeah, if we go back here, now if we run it, we should be able to see the y's. And there you go. So we ran it. You can see that these are the 200 labels. Some are 1s, some are 0s. So we basically got some data. We can also print the x's if we would like. So I'm going to switch back to the notepad. I'm going to do x. Okay, and now I'm going to save this. All right, you should be seeing the prompt now. So if I run it, you can see there's the data. Right, so we have the labels here, 200 labels, for the corresponding 200 vectors of 2. So this is x. You can see it goes from -1 to 1. Notice the exponentials there, and it's a 200 by 2 right? We can also, it's also always useful to print the shapes, so we can go back to here, right? And just print the shapes instead of the data itself. You can see X and Y shape. We go back to the terminal. And there you go. So we have the labels are 200, and then the data X is 200 by 2. Pretty easy. Any questions so far?
I don't have any questions.
All right, good. So now we have our data. Our data is set, and then we'll play with the data. And now if you remember before, we had basically talked about the multi-layer perceptron, right? So we had talked about the multi-layer perceptron, and now we're talking about deep neural nets. So let's just go over to the whiteboard for a sec, and let's take a look at that idea. So here's the whiteboard. So if our data, our current data, X, right, is 200 by 2, with label Y, which is 200 basically by 1, then those are important pieces of information for our neural net. So far, we've learned about multi-layer perceptrons, right? So the multi-layer perceptron had basically 3 layers, right? It had the input, it had the hidden layer, and it had the output. Okay, so it had these 3. All right, so the input here is going to be based on the number of features. So this is F1, this is F2. So then here, this is going to be F1 and F2. Usually because it's X, we call it X1, X2. That means that there are 2 here. The dimension here is 2. Now here we know there are 2 labels. So the classes, we have 2 classes, right? We have 0 and 1. So there are 2 labels basically. So that in a neural net can be either 1 like this, like we've seen with the perceptron, where we have a value, and if it's greater than 0.5 or less than 0.5. Also in deep learning, sometimes we have, if we have every class is represented as a node, so that's another possibility. Okay, this is called one-hot encoding. So one-hot encoding is basically what, let's say I have 3 labels, like in the iris data set, right? So I have Virginica, versicolor, setosa, so 0, 1, and 2. So one-hot encoding means that I represent this, because there are 3 labels, as a vector of 3. Right, so it's like 0, 1, and 2. And then each one is just like, this one would be 1, 0, 0. This one would be 0, 1, 0. This one would be 0, 0. Okay, this is called one-hot encoding. And that's something that you sometimes do with deep learning. Okay, and then in between we have the hidden layers. So here we can have so many nodes, so then we can make the connections. And then we have another set of connections over here, like that. Okay, so of course this one is pretty simple just because we're starting, but this can get more complex. You can have not just 2, but n, and usually this is limited to, like, 10 or less. because you don't really have that many labels. Remember that this is still supervised learning. Supervised, and it's also, classification. Classification, okay? So that's what's important. Now, these dimensions are important because they allow us to set the architecture. So that's what we're about to do, right? We're about to set up this architecture. And for that, we're going to use our TensorFlow program. So let's go ahead and let's go back to the notepad. Okay. So now I want to let me just get a couple. All right, so now we need to separate our data into train and test. All right, so to do that, let's take X train, and instead of doing the split, which we could do, let's just, because this doesn't really matter, it's already randomized, we can just take X like this and do, 100, right? So basically the first 100 will be for train. Okay, so then Y train also. So we take Y and just until 100. And then we have our X test. We could have also, as I said, done the split, and we might do that later, but here, and the rest basically from 100. Right, in all the columns. So basically we go from, 1 to 100 here, 1 to 100 here, and then here we go from 100 until the end. We do the same for Y. Just like that, okay? So we have our data. Okay, and now that we have our data, the next step is to proceed to create the neural net, okay? So the first one is actually going to be just what we learned before. Now, an interesting thing about this is, you know how we started with perceptron, linear regression, logistic regression, multi-layer perceptron? Well, as it turns out, we can write logistic regression here as well, okay? We could also do multi-layer perceptron. Multi-layer, just like we did in pure NumPy, but here we're doing it, in TensorFlow, and then finally we'll do a deep neural net, which a deep neural net is something we have not done. But you will see that they're actually very straightforward, because the only difference, if we go back to the whiteboard again, the only difference is that if I do something like this, right, where I have logistic regression, the multi-layer, perceptron or a deep neural net, right? The only difference is considering the inputs. So they all have inputs, right? So they have inputs and they have an output. And then they have an input and an output, and they have an input and an output. So let's say that the input is 2 feet. No, let's just say 3 features. The output is 2. So it's always 3. And the output is 2. The only difference with these is that for logistic regression, there are no more layers in between. That's it. We can just create it like that. That's logistic regression. With a multi-layer perceptron, we have a layer in between, just one layer called a hidden layer. So remember, this is input, output. This is input, output, input, output. But here we just have one hidden layer. So here we have these connections. Like that. In a deep neural net, we can have one or more. We have more than one. All right, so it can have, that's still multi-layer. But then if I add 2, it's now a deep neural net. If I add 3, it continues to be a deep neural net. So it's just more. Just like that. You see this is what makes it deep, right? The fact that there's more than one. Okay? And so that's it, right? So then, therefore, we can, if it's got no hidden layers, go back to the notepad. So I can say no hidden layers, right? No hidden layers. That's logistic regression. Okay. So now we start to create our model, right? So we start to create our model, and you'll see it's pretty straightforward. So first we create this object of model. And now we're going to use keras. Okay, so we're going to use keras for this. So I'm going to say tf dot keras dot sequential. And this is just the object that allows me to start to create the layers, the connections in the layers. So now let me just run this to make sure everything is running so far. I'm going to switch back to the terminal here. Right, you should be seeing the terminal. So now if I run the code, and you can see now this time around, it started to give us information. It says, TensorFlow platform CPU. This TensorFlow is optimized with deep neural network library and so on. So you can see it is now calling TensorFlow itself. Okay, it's calling TensorFlow itself. And that's pretty good, right? So that's what we want. So we can now begin to build our deep neural net. So let's start here with a, so I'm going to go back. All right, so I'm back at the notepad here. All right, I've got TF keras sequential. Now, what I want to do is I want to set the layers. So what you do then is you grab the variable model and you set add. You're going to say add here. And then there's various ways of doing this, but usually you take something like this. So you just open and close the parentheses. And then now in here, you can add as many layers as you want. So in my case, I'm just going to add one layer because it's just going to be, one. So I'm going to say tf.keras.sequential. layers dot dense. You see that? So it's a dense layer. What a dense layer means is a layer that is fully connected. Every node is connected to every other node. Okay? And so now I can open parentheses, and again, close parentheses down here. And now we can specify the parameters. Okay? All right, so what do we want to specify here? Here we want to specify, we already will know, you know, we need to specify the inputs and the outputs, right? So if we look at whiteboard, remember, we're on this one, right? Logistic regression. So we need to specify how many inputs we have here and how many outputs we have there. That's it. It's super simple. So we really just need one layer that connects inputs to outputs. So to do that, we're going to specify, let's say the units will be 1 in this case, right? So we're just going to have 1, or we could have 2. It just depends. So in this case, I'm just going to set it to 1. Units equal 1. And then I'm going to say the input shape. So the input shape. And then here, because TensorFlow can handle tensors, which are basically n-dimensional matrices, right? You can specify multiple dimensions here, but we're just going to specify 1, which is how many features we have. So in that case, we have 2 features, right? Because of this, we created 2 features, right? So our x data is 200 by 2. So then we specify here the number 2. Does that make sense, guys?
Yeah, that makes sense.
All right, so we have then, so really, I guess for this to be consistent now, let me go back to the whiteboard. And the shape of this, actually, I should have done this correctly. So really, given our data, our architectures actually look like this. So this is logistic regression. This is the multi-layer perceptron, MLP. And this is the deep neural net, right? So this one is just like very simple, just like that. Okay? So that's our logistic regression, 2 inputs and 1 output. Because we're not doing it one hot encoded here, but we could if we wanted to. Okay? So let's go back. So then this is what we're doing, 2 by 1. So if I go back to the code, you can see I have units is 1, that's the output, and then input shape is 2, that's the input. After that, we just need to specify the activation function. So if you remember, we discussed this last week, and we had said that the activation function would be sigmoid. Right, so you should remember, hopefully by now, that what that means is, go back to the notepad, that the output here is passed through a function. And that function is, the S-shape function, right? That, does something like that, right? So the S-shape of the values. So it basically, the values will be from 0 to 1. Even though our values currently could be infinity, we just want zeros and ones. Why do we only want something between zeros and ones and really just zeros and ones? Because our labels are all either ones or zeros, right? We already printed this out, if you remember. But it's basically because of the labels. Okay? So if we look at the notepad then, right? Okay, so that's the sigmoid function, right there. Then, keras has this really neat feature that you can do a summary of the model. So you can do model.summary, and it tells you the number of parameters, right? So now we can run this one, for instance. So let me switch to the prompt. Okay, now we do something like this. Right, and you can see here that we ran our model. It's a sequential model. And then it says here that it's got the output shape, right? It's just got one feature, but there's a total of 3 parameters to calculate. What are those 3 parameters? Well, you should know that, right, by now. What are they? If we look here, parameters are W1, W2, and the bias. You guys remember that? So those are the parameters, the weights, matrices, and the bias, right? So you can imagine the more nodes we have, the more layers we have, the bigger the number of parameters will become. Okay? But that's pretty useful. Did you guys see the, yeah. All right, so now let's continue. We are back in the notepad. We are back in the notepad, and let's now finish it up. So we need to do model.compile. Again, we can open it here, close it down here. And now we need to specify the optimizer, which, if you remember, that was stochastic, gradient descent. So it's actually called stochastic gradient descent. So we can just say TF keras dot optimizers. And there's another one called the atom optimizer, for instance, but here we're just going to do this one. So it's stochastic gradient descent. That's GD. All right, and that it's as simple as that. You see, how we had to code all of this from scratch with NumPy before, and now with Tensorflow, we no longer have to do that. Okay, so this was the for loop that we had for this number of iterations, do this and that, now it's just very simple. The next thing is the loss function. Do you guys remember the name of the loss function for logistic regression? Right, so it was called cross entropy. In this case, we use the binary because we only have 2 labels, so binary cross entropy. Here, if you were doing this for a multi-class problem, you would need something like multi-class cross entropy. A little bit different. All right, so that's the loss. And then we have the metrics that we want to print out. So keras only provides accuracy, but you can easily calculate the other ones. So here we can do tf.keras dot metrics dot binary accuracy. Accuracy. All right, and that's basically it as far as the model is compiled. And now finally, we can just fit the model. So this was where we did fit and predict. So here I'm just going to do fit. So we can always create a variable called history that we will use to keep track of things. So here now we're going to, this history will take the model dot fit, open parentheses, close parentheses. All right, and now we give it the data. So X train, comma, Y train, comma, then we want to give it the validation data, which is the test data. So validation, and we can say, this is actually validation data. And then we can say here, X test, comma, Y test. Okay, so pretty much what we had done before, very similar. Okay. We also specify the number of iterations. So this is just like before in the for loop, number of iterations. So epochs equal 200. We also have this option to specify how it should grab the data, one item at a time or in batches. So we can actually say that we want a batch size of whatever, let's say 2. Okay, so it'll grab, instead of grabbing one sample at a time, it grabs 2 samples at a time. Okay. So all right, so the last thing will be if we want this to be verbose or not. So verbose, I think true is 1, 0 is false. So therefore that means that it should output the accuracy, how well it's performing. So let's go ahead and do that. So I'm gonna save it. Okay. And now I'm going to run it. Okay. Oh, sorry, I need to share this. Yeah, that's my mistake. All right, I'll run it again. But you can see it's actually running there. Right, and it finished. So let's actually start it again. All right, so you can see it's gonna run. It runs pretty fast. And what it's doing is it creates the model, and now it's training, right? So it's training, and it's giving you there, you know, the values. So we'll take a look at how it's performing. You can see the values. All right, so you can see actually this is pretty good. You can see here in the last iteration, right? For the train, the loss, you can see the loss is, look at the loss. The loss starts at 0.885, right? So the loss starts at 85. Then it starts to decrease, which is good, is what we want. We want the loss function to go down. Oops. And the loss function ends up being around 68%. Here we have the accuracy is at 65, okay, on the train set, and the accuracy on the test set is 71. So this data is not very, you know, and it makes sense that the results are not better given that the X data was created randomly, right? So it's not very, and still it was able to pick up something there. But basically tells you that you get an accuracy of 65% in the train set, 71% in the test set. Any questions? That's it as far as logistic regression. Now, what we're going to do is we're going to repeat the exact same exercise, but this time around, we're going to make we're going to add more layers, right? We're going to add more layers and create a deep neural net. So now we're going to add hidden layers. So what that means is that we are going to, if we go back to the whiteboard, we're going to go to the DNN. And now we have input, output, but we're going to add layers in between. And so on, like that. Okay, so we're going to add more layers. We're going to say that we want these to be of size 4. And that's just so that we can try something out. And of course, remember that all of these have activation functions. They will have the activation functions, just like here we talked about the sigmoid. They will have activation functions, but instead of only the last one, this one will have the sigmoid function. So this one will use sigmoid. These are all going to be a different one called the Relu activation function. Okay. Now Relu is a little bit different. So if you look at sigmoid, right, it looks like this S shape. Relu is a little bit different. Relu takes any input, right, on the x-axis, so from -infinity to infinity, right, like that. But instead of giving you like the S shape like we had talked about with the sigmoid, right, where this is 1 and so it basically compresses everything to be either a 0 or a 1, regardless of what the value is in x. So this is x and this is y. Right? So you get, this output based on whatever the input is. Relu is a little bit different. It's a very interesting function. Instead, Relu looks like this. It looks like that, and then it looks like this. So they call it a hockey stick, right? A hockey stick, and what that means is that if the value of x is negative, right, for any negative value, the output is always what? 0. But as the value gets positive here, right, going, positive on this side, then the value just becomes the same value, so it's proportional. Okay, it's proportional. So Relu also sometimes is just called the max of 0 or x, right, which is the same thing. So if x is negative, obviously the max will be 0. Otherwise, if it's positive, it'll just be the value. But that's the Relu function. So it'll compress. Basically, it makes all negative 0, and then every positive is follows that. Basically, the same value, x. All right. So now, since that's the function that we're going to use, we just need to create our architecture. Okay. So we go back to the command, or actually go back to Notepad. All right, and we're going to do here our deep neural net. DNN. We're going to say, deep neural net with, I think this will have 3 hidden layers. Okay, so we can repeat the same process. Model dot, or model, tf dot keras dot sequential. Right, so we just create the object. Now we're going to add the layers to it. This is another way of adding the layers. I actually like this way better. So model.add. And then we're going to say tf.keras.layers.dense. Okay. And then in here, we can specify the number of units that we have in this layer. So units will be 4. That's the first hidden layer. The input shape. The input shape will be 2, nothing, right? So 2, nothing. The activation will be Relu. Okay, and that's it. So that's the equivalent in the diagram of defining the first hidden layer. Okay, the first hidden layer. So remember, this is the input, this is the output. We just defined that one. It has 4, and the input is 2. Okay, now we need to define the next 2. Okay, need to define this one and this one. Okay, so to do that, we are going to go and just add another layer. So I'm going to say model.add, and then tf.keras.layers.dense. Units equal 4, again, because it's got 4. No input shape anymore, because that's already been defined. So we just do the activation equal Relu. Just like that. And that's it. That allows me to define the second one, then the next, the last one, the third one, model.add. tf.keras.layers.dense. Units 4, and activation equal Relu. Okay. Just like that. And then finally, the last layer is the output layer. So the last one is, go back to the board. Now we need to define this one. Remember, this one is a sigmoid because we want the values to be between 0 and 1. So we want the values to be between 0 and 1, given that our classes are between 0 and 1. All right, so let's go back to the code here. And now I'm going to add the last layer. So I'm going to say model dot. So I'm in the Notepad++. So I'm going to do model dot add. And I'm going to add the new pf dot keras dot layers dot dense. And then here I'm going to specify the number of units. In this case, remember there's just one. All right, there's only one neuron for the way that we're doing it, which is that one, right? So we have one neuron there. So I've got one. And then here I need to specify the activation, which remember will be sigmoid in this case. So we have a sigmoid activation there. Okay. And that's pretty much it. Then we can do model.summary. Let's do the summary first. You'll see how many, this will have a lot of parameters. You'll see how by having more layers, more neurons, you know, this can become a lot. So I'm also not going to run this one anymore because I don't want, it's a while to run. So I'm just going to comment this one out. All right. And now let's run it. Okay. Oh, I keep forgetting to do that. Sorry. All right. So show the prompt there. All right. I'm going to run it again. And you can see here now there are 57 parameters. And this is still a very tiny neural net. Okay. But now it just went from 3, the initial one, to 57 parameters. You can see the architectures right there. Right. So you have dense, dense, dense. You have 4, 4, 4, and 1. All right. So that's the architecture, the summary of it. Now let's switch over to Notepad again. And once we've established the summary, the next thing we want to do is do we want to compile this. So again, we're going to specify model.compile, open parentheses, close parentheses. And then now in here, we need to specify the same things again. So the optimizer is again going to be tf.keras.optimizers.stochastic gradient descent. Then the loss function will be tf.keras.losses. And then now binary cross entropy. We can do that one. And we can report the metrics, which are going to be tf.keras.metrics.binary accuracy. So on Wednesday, I will show you guys how to do this with more. So we'll take more comprehensive problems. But today, just a simple introduction. So metrics, tf keras.metrics.binary accuracy. Okay, and remember this also you can use for your term project. I know you guys are just getting like a data set, so you can run your data set with all these tools. You can try different architectures and so on. All right, so now that we've specified these parameters, we are ready for the last part, which is to do the fit. So I can do history equal model dot fit, and again, oops, open parentheses, close parentheses, and then in here we can specify. So first the X train, comma, Y train, comma, and then we need the validation data, which is the test data, so validation data, and that's going to be X test, comma, Y test. It should be pretty much what we did before. All right. And then after that, we have the number of epochs again, which is the number of times that you look at the data. So you look at all the data 200 times in this case. Also, we want to read the data in batches. So instead of reading one item at a time, this is in particular useful if you're running like a GPU, because in a GPU, you can perform multiple tasks at the same time. So you take a batch size of something, in this case, like 2, let's say. And then we're going to do verbose. In this case, we're going to set it to 1 because we want to see the results. All right, and that should be it. So now we're going to run our deep neural network. So this is the first time in this class that we will be running a deep neural network. A very simple one, but still, this is deep learning now. All right, so I'm going to save this file. Go back to the prompt. If there are no errors, this should run. Oops. All right, so let's go ahead and run it. Ah, there's an error. I think I have a typo. Okay. Yeah, so this should be verbose. Okay, save it. Back to the prompt. Run it. Right, and you guys can see it's running there. All right, it finished. What do you guys think? Do you remember what the results were when we just did the logistic regression?
I think the loss was in like the 60s or 70s.
Right, and look at the loss now. It's in.
Yeah, now it's 3.
Yeah. See the accuracy?
100%.
100%. And then the test set, 93. Do you see that? So deep neural network was able to achieve much better results than just logistic regression. You guys see that? Pretty much everything else was the same, right? Same data set. It was just the architecture, so it had more power to learn more information, to separate the data more accurately than before. So as it turns out, logistic regression is a linear classifier. Deep neural nets are nonlinear classifiers, right? So what does that mean? Now let's talk about, and in particular, because this data is called the XOR data. So now kind of, to give you the intuition here, all right? So the data set that I picked today is called XOR. So it looks like this, let's say, right? So it's a problem. Let's imagine, just intuitively, that it looks like this. Do you see that, guys? These are the two labels, the circles and the X's. Now, if I ask you the question, is there a line, some line, that can perfectly separate this data? Any linear line Does it exist? That
No.
No, right? It's impossible. There is no line that could separate something like this. Remember that ultimately, like we learned in linear regression, you're creating these lines, right? You're creating these lines. So you're creating something like that with logistic regression, but that does not work intuitively. So what linear regression does is that it's a linear classifier, produces lines to separate the data. This is not possible. The only way that we could separate the data perfectly would be if we had a line that looks like that. You see that? But that line is not, it's not a straight line. It's a curve, right? It's a curve. And that's where neural networks come in, okay? So let me actually do this instead. Let me do this. All right, so I'm gonna just say, looks like a square almost. But anyway, it's the same one. It's supposed to be the same one. Okay, now in logistic regression, change to another color. In logistic regression, and let's say logistic regression, it's a linear classifier, it's a very, very good linear classifier, but it can only do that. So there is no, probably the best line for this would be something, I don't know, maybe here, like a line like right there might be the best possible line that it can get, I think. That's not very good. Now, the perfect thing would be something like that. Logistic regression cannot do that. However, deep neural networks, you want to understand intuitively that they can approximate this circle. How do they do it? Well, if you want to think about it intuitively, think of this one, the hockey stick in Relu, as an approximator. Right, so if you look at the Relu, it kind of looks like that, right? It looks like a little hockey stick. And so in a sense, you can think of it as the neural net is adding all these little hockey sticks. You see that? It's kind of like, you know, intuitively we can think of it that way. And so they approximate, ultimately, if you use your imagination, you can see that they approximate that circle. And so that's why we saw accuracy of 0.71 on this one, I think it was, and this is 100%. Does this make sense, guys?
Yeah, that makes sense.
And so that's what a deep neural net can do. A logistic regression algorithm is a linear classifier. A DNN can approximate. It's a non-linear. It's what it's called, non-linear, right? So, you know, polynomials, whatever, curves of some kind. In this example, the data, you know, something like this. And so that's basically the idea. And that's why we were able, as I said, to achieve almost perfect accuracy. So it's really good, actually. Okay. All right. And so that's pretty much it. At this point, we have completed a very simple. So if we go back to here, right, we have completed a very simple, the XOR classifier. We built a deep neural net, right, that looks like this one, right? So we built that deep neural net. All right. So now, in the next class, we're gonna, you know, work with more complex kinds of things. So one thing I want to try actually is I want to see if I can bring in iris and MNIST into this data. So to do that, I actually need to go to the notepad here. Let's switch over to the notepad. and I want to add those data sets. So I can bring them from scratch. So let me see. So to do that, I would need from, let's say, let me do that here. So from, so import, and I think I need to install this, Tensorflow data sets as PFDS. Let's see if that's available. So I need to run this code now. It'll probably give me an error. Right, so you should be seeing the prompt. Right, and it says no module TensorFlow datasets. So I think I need to install it. Then I'm going to run pip install pip install TensorFlow datasets. All right, let's see if that works. All right, that's a good sign. So you guys have to do this also on your end, on your computer, right? You have to install all the data sets. All right, so that's promising. So now if I run pip install, oh, no, not that, sorry. If I run simple deep learning. All right, perfect. So that means that this time around, it did detect the library. So then next time around, what we want to do is we want to load our data. Okay, so we're gonna try to load the iris data set. And the MNIST data set. So I'm gonna do now that I know I have this, I'm gonna go back to Notepad. And I'm gonna say iris equal tfds dot load, and I want to load the iris data set. Okay, let's just try, and then let's see if then I would do X train, let's just say X train, and I'm going to load iris train. Actually, I'm just going to say iris here. Okay, I'm also going to, I'm not going to fit anymore because we know that works. You can just comment that out. All right, so this is just for next class, but I want to make sure this is ready. So I've got iris train, and now I just want to print X train iris dot shape. Okay, so let's see what happens. Let's run this. I'm going to go back here. Okay, so that was about downloading the data. Oh, okay, so the object. It's okay. It's the way that it loads the data set. All right, so I'll figure it out. It's probably just in a different format. All right, I'll work on this next time. All right, I don't want to confuse you guys with this, so I'm gonna just comment this out for now, and I'm gonna make sure this is running. This I will post this on the a link to the on the GitHub. So let me just make sure it works. So I just saved it. All right, there it is. So you guys can see it's running. So you can play with this one today. You know, kind of download it from the GitHub. I will on Wednesday. We're just going to take another data set, something a little bit more like Iris or MNIST, and then kind of go through, you know, slightly more complex deep neural nets. All right. So that's it for today. If you have any questions, stay over. Otherwise, I'll see you guys on Wednesday.
I actually have a